This is the CAD2 Week 2, Part 2 tutorial. So in the last part, we created this model, properly checked the mass, and we filled out the properties in our file properties. Now we're actually going to take this model and we're going to convert it into a blueprint and make a copy of that engineering drawing that we used to create it. So when creating a drawing, there's a few ways you can actually start a drawing. When you have the model open, you can click File, Make Drawing from Part. Now, the only thing to be aware of with this is going to grab whatever your default template is, which can only be one file. So if you switch from metric to inch at any amount of frequency, you don't want to start a drawing this way because usually you'll set it to be your inch and it'll always make an inch drawing. And this is a metric part. So the other way is to go File, New, just like before. We're going to go to metric instead of English. And again, if you start in here, you need to go to advanced and then metric. And the third option is actually our drawing template. And you can see a preview of a drawing when you click on it. We're going to select that and hit OK. Now, it has created and opened a drawing for us. And we need to actually insert some drawing views. You can see over here, we've got some model views in a preview. But there's another tool we can use on the right side, which is the third option, down from the top, which is called the View Palette. Now, personally, I like to use the View Palette to get my views because it's a little more thorough. Now, we can select this over here and go to Next, and we can create individual views, but again, I don't really like the Model View tool. So I'm going to close Model View, and I'm going to go to View Palette over here. I can hit the pull down and select from Open Models. If you have your model open, it'll be right there. If you don't have your model open, you can browse using this button and select from there. The reason I like the View Palette is it gives me a preview of every single view and what they look like on the model. Now, I know I want a front view, so I'm going to actually take and drag my front view in. And now that I've created my front view, I'm in the Projected View tool, and you can see that up here. This is going to create new views based on the first view. In drawings, every view should come from one starting point or parent view. So from my front view, I can go up and make my top view, and I can go up and to the right and make my isometric view. Now that I've got all the views I need, I can hit Escape. Now you'll notice when I move my front view, my top view goes with it, but my isometric view does not. Once it's created, the isometric view is independent and can be moved freely, but front, top, right, and all of our other standard views are automatically locked and in line with each other. Another thing you'll notice is that the drawn by, title, material, and weight all populated automatically. That's because we set our properties in the model in the last tutorial. If you didn't do that, your title and drawn by are going to be blank, and you'll have to do that manually. Now, for this drawing, we're just going to replicate the drawing we used to create it, just to get used to and learn where all the tools are. So the first thing I actually want to change is the scale. Everything else is going to be placed based on the views, and if our scale is different, it's going to make it really hard to place things correctly. On the original drawing, our scale was 2/3 down here. So we need to change our scale here to match. You'll notice scale is listed in the title block. So we can't just click on a view and change the scale here. We can, but it would be incorrect. To change the scale in the title block and have the drawing views go with it, we are going to go to the feature tree and right-click on Sheet 1, and then go to Properties. Here it lists the sheet scale, and we can change that to 2/3. And when I hit Apply, it'll give me a pop-up. Do you want to scale the annotations? We don't have any, so no, we'll just hit OK. You'll notice those views got bigger, and this also got larger. Okay, our views are scaled correctly. Let's take care of a few other basic, every drawing things. I'm going to fill out my revision table. There's always a revision table, always needs to be filled out, and it's filled out manually. This is Rev 0, no change number. That's what ECN stands for, is engineering change number. It's the initial release. That's our standard set for a new drawing. It was done by me, or in your case, you, so put your initials in, and whatever date you're working on this, which is 1/25/26. Okay, that's filled out. This is all filled out. My title block and revision table are good. I don't have to worry about them. The next thing I'm going to do before I add dimensions is add my center marks, hidden lines, and deal with my tangent edges. So anywhere you have a tangent relation, you have a tangent edge. And according to the drawing standard, in the isometric view, those tangent edges should be on. We can see them here. But in our model views, our actual drawing views, they need to be off. So to turn them off, I'm going to right-click on my drawing view. In the pop-up, I've got tangent edge, and I'm going to select removed. And you can see they went away there and there. I've got to do the same thing here. Right-click, tangent edge, removed. Another thing is hidden lines need to be on. So there's holes through these parts here and here. That needs to be visible in this view. But again, hidden lines are only visible in our drawing views, not our isometric view. It's got its own set of rules. So I'm going to click on this drawing view. Now I actually can right click and there should be a hidden line option, which there's not. So we'll do it the long way. I'll click, and over here I have display style. The default normal is hidden lines removed. We're going to turn it to hidden lines visible. Now you'll notice that did it for all views, including the one we don't want it to. That's because this is the parent view. I can leave these two, but I have to go over here and say, okay, display style. You can see it has use parent style selected. I'm going to uncheck that and move it back to normal. Some people like to do shaded too, but that just burns printer ink. So we're going to leave it hidden lines removed. Okay, our views are set up now. We need to add center marks and center lines. Center marks and center lines show the relation between circular features and any axes in circular features. So I'm going to go to center mark, and you'll remember when we created it, this feature and this hole, these two holes, are in line with each other. So I want the center line to connect like it does in this view. See how the center line here connects the two and follows the pattern? To do that, we need to select a pattern center mark. So this is a single. This is a linear pattern when they're in a line with each other. And this is a circular pattern when you've got like a bolt hole pattern, which we'll use later. So I'm going to go to linear center mark. And then I need to select some features. Now, you'll probably want to go in and select the hole and the hole, which will create a center mark, but you'll notice that it doesn't extend beyond the edge of the part. But in our view here, we can see that it does. Center marks extend beyond the edge of the largest feature they apply to. So I'm going to delete this one. In order to get the center mark to extend beyond the edge of the largest feature they apply to, when we create it, we need to select that largest feature. So to create it, I would need to select the outer diameter and the outer diameter. Now my center mark extends beyond the edge, like we want it to. Now, I also need a center mark down here. This is going to be a single, which, fun fact, you can stay in pattern. There is no harm in creating a single center mark while in the pattern center mark. And that gives us our center marks. Next, we need center lines, which are used to show axes when we're looking parallel to a hole. Now, the center line tool is supposed to be a smart tool, and sometimes it works, sometimes it doesn't. I should be able to click on this face, and you can see it actually created that center line for me just like I wanted. But I can try it again down here, and you'll see it only created that one. It's not creating this larger one. So I'm going to have to create that one manually. To create it manually, I just need to select the two features I want to mark in between, which would be the hidden lines for that hole. And you can see that creates the center mark going vertically through that part to show that hole. Okay, all of our center marks are created. Our drawing views are set. Let's take care of finishing up the isometric view. Now, the isometric view is supposed to be at its own scale, and this is to help avoid confusion and to try to stop people from measuring off of a perspective view. So we're going to modify the view of this and then add our isometric view scale none note. So I'm going to select the isometric view, and I do have scale. I'm going to use a custom scale, and the isometric view is supposed to be scaled smaller than the rest of your drawing. So I'm going to make it 1/2 by doing 1/2, and that sets it to a 1/2 scale. Now, because this is now at a different scale than the rest of the drawing and the sheet, we have to say the scale. That's part of why we have that note. Now, you can take the note tool, and when you hover over the view, you see how I get that purple box? That means this note is going to be attached to that view, so if I move the view, the note will go with it. That's really important for when you have to make a lot of edits. I'm going to click to place this note, and I can just, in full caps, type isometric view, scale, none. I can center it. I can add my space that I missed here, take the top and make it bold. But you can see that's kind of tedious. Once you've created it, you can save it out as something called block. We actually have our default note saved as a block. So you'll notice in annotation, that's the drawing tab, we have blocks. If I click here and go insert, it's going to take me to the insert block tool, and I have to browse. Now, if your templates are not set up, which on the student computers are not usually, it's not going to open you right to this folder. Usually it'll take you to your C drive. You'll have to go to local disk C, Met templates, SolidWorks. There'll be a SolidWorks blocks folder. Then you can grab the ISO view block, and you'll see that that's got the scaled, already set note ready for you. So I'm going to place that, delete my hand-drawn one, and then reposition it. Now, you notice when I put it down, I had that purple box highlighted. That means that I can drag and move this view and my note goes with it. If it's not attached to the view when you place the note, it won't move with the view, which gets really tedious really fast. Okay, now that all my views are set, it's time to finally add some dimensions. So I'm going to copy the dimensions that are on my drawing. So I'm going to go up to Smart Dimension. Now, some of you may have used in the past the Model Items tool. The Model Items tool pulls dimensions right from the model into the drawing. I'm going to demonstrate it, but I'm going to demonstrate it to show why I don't like it. So I'm going to select Entire Model and hit OK. Now, in this case, it worked okay. All my dimensions need to be adjusted and moved. The positioning's not great on them. And as I move them around, we run into a number of issues. Certain views are in places I don't like why is the 28 for this going into the circle instead of out here? All these issues just usually end up making it so that it's faster to just do the dimensions manually than to use the Model Items tool. So with that in mind, I'm going to Control Z to undo my model items. It's gone, and I'm going to do it manually. Smart Dimension. Now I need to dimension from hole to hole. If I click these, you'll notice it places it with my extension line running all the way to the middle, which is a problem. Per the drawing rules, we need to have a gap between our dimension extension line and our center mark, or the edge of our part. This didn't create a gap. So I'm going to delete this dimension, and I'm going to Smart Dimension from my center mark specifically. Now you'll notice it actually left a gap between the extension lines and the center marks. Those gaps are really important, and they're one of the things I'll be checking in every drawing you make. Now, I like to make my dimensions centered, so when I click on my dimension, I get this little pop-up. And this pop-up gives you some quick edit options. All these options are also available over on the left side of the screen, but this keeps you near your cursor so you don't have to move around as much. My second option here is to center, and that'll just put my dimension in the center. It looks clean. Okay, moving on. Center mark to this edge is 15, so I'll place that. and again, I'll center it. The width here is 12, so do that. Now, dimensions should be grouped whenever possible. It helps keep things looking clean and organized. So as I move this dimension around and down, you see how I get those yellow preview lines showing me the alignment of things? I want to follow those whenever possible to keep things grouped and in line. It makes your drawings look a lot cleaner. I'm going to dimension this radius up here, and again, I'm going to bring it all the way up till it's in line with my 115. Now, if I don't like how high that is, I can come back, bring my 115 down, and then bring my radius back down to match. That's okay. I'm actually going to bring that radius in just a little bit. All right, smart dimension the diameter of this hole. And again, I'm going to pin it right below the 15, keeping things grouped and nice and clean. Dimension the diameter here, radius 30. Again, I'll go up till it's in line with the 115. The diameter 30, bring that till it's right under my radius 30. I'll do my length of 50 from center line to center line, or center mark to center line. Place it, dimension, centered. Now this one doesn't quite fit in line with those. It does, but barely. I don't like quite how close to the part that is. I'm going to move it down a little bit. And to be picky, I will move these down in line with it. Again, it just keeps things looking clean. It's part of doing professional drawing. Okay, dimension here to here, that is 28. I'll put that one out to the side and center it. And then from this center mark to this edge of the part is 14. Now I don't like how this looks inside here. This isn't wrong, but I think it looks cleaner if you pull it down and put the dimension outside. So I'm going to bring that down to here, and I think that looks a little cleaner personally. It's not wrong if you leave it in between those so long as it's not overlapping. But I think that looks better. Okay, I think that takes care of all the dimensions for our top view. We can go down to the front, smart dimension from this surface. Now down here, your selection is important. You can see as I move around, I've got 3 different highlights. I want to pick the one closest to the edge so that it leaves me an appropriate gap. However, when you dimension to a radius, the gap is nearly impossible to see. So I'm going to manually adjust that gap so it's more visible. If I click on the extension line, I can see a little blue point, and that lets me actually move that. So I moved it, but you can see it didn't update. I have to force it to update and hit the reload button, the little stoplight button. And now that line moved over and I can clearly see the gap. That's more visible and visible enough to see it on the drawing normally. So that's perfect. Well, smart dimension, we have from here to here. That's 50. Again, I'll bring it down, center the dimension. Got our radius of 15. Now I want to make sure that this doesn't cover the end of my gap, but I've got enough room here that I am able to place it in between, but I could also place it up here. The whole point is we want to make sure that it is not covering the end of it and making it hard to see. And then I've got the diameter of the small hole, and that is 12. And I'm going to place that up here this time. Again, on my drawing originally, I have it in here. That's fine. Up here is also fine. It's whatever looks cleanest. How clean something looks is subjective, but there are things that do generally look messy. All right, last dimension is the 15 over here. And again, I'll bring that down till it's in line with the rest, just for that sake of consistency. I can zoom out or press F to fit the drawing to the screen, escape to exit smart dimension, and I'll just kind of move this around until things are centered and positioned roughly. Move this up into this corner, and that looks pretty darn good. So I'm going to go through my checklist. Now remember, the drawing checklist just contains everything that should be done in the drawing. As I went through and did all that, you're probably thinking, wow, there's a lot of rules and things mentioned. Things we're going to learn and get used to as we go. This is a checklist to basically help you keep track of those rules until they start to become second nature. So, title is filled out. Yep, my title's filled out. That's a check. Material is set. Yep, I can see gray cast iron. Drawn by and title block is filled out. Yep, there's some initials. Revision box is filled out. Yep, revision box is filled out. Isometric view and note is in place. Here's my ISO view and my note. Tangent edges are turned off except isometric. Yep, that was one of the first things we did. No tangent edges here, but we have them there. Hidden lines are turned on except isometric. Hidden lines here and here, nothing here. Any necessary notes listed in the top left corner. Again, those notes that we used today were not necessary, so they are not listed. They're just there for you to help with the modeling process. If you put them, there's nothing wrong with that, but they are not necessary, so I didn't include them. Check. All circular features have center marks or center lines. We have here, here, and here, 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 and here. Check. All part features are shown clearly. I can see every part feature. We got enough dimensions to create this. No dimensions are inside the part. None of your dimension numbers are allowed to stay inside the part, barring some extenuating circumstances. So all of our dimensions are outside the part. That's good. All dimensions are listed. Can you model it? Well, we literally copied the dimensions from the print we used to model it, so I'm going to call that a good. If you're making your own drawing, it might not be a bad idea to take those dimensions and try to recreate it real quick. You'll find out very quickly if you miss something. No dimensions inside the part. All dimension text is clear and legible. Everything is nice and clear. There's no overlaps or anything preventing me from reading the dimensions. Sheet scale matches drawing scale. These are using the sheet scale, so yes, they match the drawing scale. The exception is again the isometric view. That note is mostly there to prevent you from overriding the scale on these views and forgetting to change it here. Just to remind you that these need to be the same. You're using the correct units in the drawing. This is a millimeter drawing, and it says dimensions are in millimeters here, and we see the SI. You don't want to make a millimeter drawing and have it say this dimensions are in inches. That would be bad. And finally, projected view are in line with parent view. Again, these views spawn in line with each other, and we have to keep that alignment. So with the checkbox filled out, we should be able to save and submit both of these. Now, for drawings, you are going to save them as a file, and it's okay for them to have the same name as your model, because they are a different file extension. But for submittal, you need to save as a PDF. Drawings are active and editable documents. And if you don't save and submit a PDF and submit just the drawing file, it won't open. Or it will open, but all your views will disappear. In order to open a drawing file, you need to have the model file. However, you're not going to distribute the drawing and model file to customers or operators on the floor. You're going to distribute a PDF, the universal document format. And I'm going to grade a PDF. If you submit a drawing file, you're going to immediately get a 50 on the assignment because you submitted the wrong file and I won't be able to view it properly. And giving a 50 is generous and giving you the benefit of the doubt that you didn't submit just a file name that had nothing in it. For drawings, we're always going to submit a PDF because that's the file that's distributed. It lets me grade it easier, it lets it open in Blackboard, and it's what you're going to use in the real world, so we have to get used to making PDF copies. So again, you'll save as, change this from drawing to PDF, and hit save. And that PDF is what I want you to submit. You can do the same thing with your template or your checklist. You can go File, download PDF, and submit a PDF of that as well. PDFs just submit the nicest and are the easiest to view and grade in Blackboard, and they'll make both of our lives easier. So with that, we've completed the week 2 lecture.